Number one, we don't even know in theory if our species can survive on the planet indefinitely. That's really not understood. We have no idea about that. And number two, we obviously don't know yet how to maintain a closed system ecology with humans in it. We have not managed that.
This is Andy Revkin, the Sustain What Enterprise, my blog, newsletter on Substack, and my webcasts. It's my 41st year I'm entering in writing and considering reporting on questions related to humanity and the climate and the earth. How do we build smoother relationships that can sustain not only the non-living, sustain not only the non-human world, but also our own enterprise long into the future. And that's why I was fascinated to see this new paper by a neighbor, Timothy Waring, who is a multi-dimensional professor. He'll tell you more about that at the University of Maine, just less than an hour away from where I live here on the coast. And we're recording this on a day when Maine was hit by one of these epic winter storms, which are becoming fairly frequent. You know, people talk about hurricane impacts and the like, but when you live on the coast like I do, or neighbors of mine who were trying to set up a farm for cut flowers and woke this morning to see the field inundated with seawater, which is not good if you're a farmer. We're grappling real time with getting used to change and the need for change in us. And a big part of this paper that Michael has led on, that Tim has led on, is whether evolution, both the cultural and biological evolution of our species, it's driven us to have certain patterns of response or non-response to signals, and ways we relate to each other and ways relate to the environment. And you could summarize it in a pretty dark way as basically saying evolution has led us down a dead-end street. I don't think that is necessarily a conclusion, but it could be seen that way. So I thought it would be worth having a conversation with Tim about this paper, which is part of a special issue of Philosophical Transactions B, the Royal Society's ancient and important journal, examining aspects of our Anthropocene predicament. So Tim, over to you. I'd love you to just start by giving your thumbnail sketch of what this paper says, and then we'll go into your background, what led you personally into this arena. I think it's really important for people to think about how to foster interdisciplinary work, not just within their individual sense, but in terms of who they collaborate with. And then where do we go from here? So let's just start with your, if we're on an elevator, what's your way of summarizing the thinking here? And then we'll get to how it happened and where we go.
That sounds good. First of all, thanks, Andy. It's a pleasure to be sort of on your podcast, video cast, whatever we call this, on Sustain What. I really appreciate the opportunity. I can give a quick summary of the paper. Will not do the complexity justice, and I'm looking forward to getting into that. But a colleague asked me to apply some of my research on human evolution and human cultural evolution to our modern predicament in the Anthropocene, the period in which human activities influence and even dominate Earth system processes, and from the climate to nutrient cycling to erosion. And I hadn't done that at that scale. And it was a very eye-opening kind of activity to think through all of the same questions that I've been thinking through at the scale of smaller scale sustainability challenges. So, the broad overview of the paper is that, human evolution has probably entered something of a new phase now that we are in the Anthropocene. I'm happy to talk about that more, but basically I think it's appropriate to understand the Anthropocene as an evolutionary event. And I even think that's the right way to think about it, both for us and for the planet. It's a novel evolutionary event, and in that it represents a change in the relationship between humans and human groups and the planet and their environment. And that change is is a big one, and we've been building towards it for a long time. But the processes of expansion and growth that have been happening in the past, in the way that we use the environment, cannot continue in the same way. And that's an old story. Lots of people have told that story. And we were interested in looking at that from an evolutionary perspective and trying to ask the question, what can we learn from both our evolutionary past and this sort of change of environment to help us navigate the Anthropocene in a sustainable way? How can we steer towards sustainable outcomes? So that's the genesis of the paper, and sort of the idea in a nutshell. Yeah.
And then the how would you break down the findings? Meaning, how much of it's about what's called cultural evolution, as distinct from biological. Now I remember Jesse Ausubel at Rockefeller University, like I think 25 years ago at least, was the first time he said to me, the human mind does not change, therefore technology must. And that's kind of one way to sketch this idea that there's these other ways to evolve, essentially. And we've certainly seen that. So how much of it's sort of cultural, and how much of what you're considering is more fundamental?
Right. So, I felt like I was in the right place to tackle this question, in part because I had just recently done some research and begun a sort of larger research program on long-term human evolution, which includes both the interaction of genes and culture and the environment. And so I think a primary thing to understand about humans and their evolution generally, our evolution, is that a lot of the action is in human culture, right? So easily for the last 50,000 years, perhaps 100,000 years, you could push the envelope further back as well, depending on what evidence you're looking at. The way that we've been sort of expanding and entering new environments and figuring out new ways to survive in those environments is through new toolkits, new ways of killing animals, of hunting, and the invention of agriculture. It's our cultural sort of capacities which have made us more effective. So a lot of the paper here is also about human cultural evolution, because genetic evolution is a lot slower. And so, but the special thing is to understand human culture not as some rational product of sort of pure design and intention, but also to understand it as a really complex and evolving system that does produce really sophisticated and complex designs, but also is far from imperfect. Right, it's a very sloppy system. This paper is really a lot on the cultural aspects, and I think you've put up the perfect picture there, and that is this picture of the evolutionary ratchet that we think, so we came at this and thought, well, what has the evolution of human interaction with the environment looked like through much of evolutionary history. And those two sort of darker bars on the left is sort of a characteristic feedback loop between the adaptive capacity of our cultural inheritance, right? When you are born and you inherit all sorts of knowledge and skills and institutional options, right? As a result of the population of humans you're born into. And then, that cultural inheritance, grants us huge amounts of access. And then, because, human groups use culture so effectively, those groups, when they're, will often grow and proliferate. So we see this feedback generally in human evolution about the adaptive capacity of culture and the strength and size of human groups. And so those are the part on the left. What we added to that simple model for this paper is that this all filters through the environment, right? As the human a population figures out, arrives in a new environment, learns the nature of the natural resources that are there, and comes to be able to consume them more effectively, or process them, or trap them, or what have you, farm them. The group then grows. It has more minds. Because it has more minds, it becomes even more effective, and maybe it grows large enough that it becomes multiple groups, and on and on. And so we see this this evolutionary ratchet, right? A positive feedback process that has characterized most of human evolution, and has resulted in us sort of conquering the planet, if you will. So this is a common story, right?
Yeah.
But it's really only half of the story, because what we're interested in is how do humans manage the environment? So if we take a sort of we zoom into this question, it's not just that human groups have grown in scale and size and power and environmental impacts. It's also that we have developed some very sophisticated cultural traits, right? Systems and behaviors and institutions for environmental management. And this is a good thing, right? This is a positive part of the story. We have systems for environmental resource extraction, right? Hunting and agriculture and pastoralism and aquaculture, right? And even, of course, mining, right? Irrigation. And then we also have systems for managing those resources. So for extraction and for management. So this might include, irrigation systems, harvesting restrictions of various sorts, penalties, and environmental agencies to make sure that the environment stays clean, nature preserves, anti-extinction policies. So these are two different types of sort of cultural practice that, and I want to emphasize, these are important at the level of groups, right? Of nations, of corporations, states of different sizes. And so this is good news, right? And the good news is clearly that humans can and do preserve the environment, right? We've done it many times. We have figured out ways to cooperate and to share and preserve key resources. And so that's the good news, right? And so we need to take that into account, and we need to understand that process actually better than current science does. However, the Anthropocene has also at the same time led us to consume more and more and more. And so
right.
We have a question now that we've arrived at this Anthropocene juncture, which is, how does this evolutionary ratchet of sort of the success of always consuming more, how does that unfold now that we're in the Anthropocene, where humans are already sort of spread across the globe, right? We've filled up the globe. We're already consuming kind of everything.
Right. That's the planetary boundaries, and as
Yes.
Roxton and others talk about.
Exactly.
And to me, I mean, I remember, God, it was like sometime in the early 90s, I think, I began posing the question by looking at bacteria smeared on a plate of agar, and which do get constrained when they run out of resources, and humans, and asking the question, is there anything to distinguish us from bacteria smeared on agar as we become more technologically potent? And we're just sort of, so I guess you're now getting us to the darker side of what could play out.
That's right. I think that's an important analogy, and I do think there is some very serious implications of the way that we're looking at it here, which are rather gloomy, right? So we wanted to ask this question, right? How does it relate? And thank you. You're doing my slideshow for me. I actually have some slides here, but this interface is new to me, so thank you so much. I'll put up some others if we come to need them. That figure is a great one, and that kind of I'll explain it here in a second. So basically, we're looking at three major components here. So the question is, now that we have a planet that's filled with humans, can we just simply develop environmental management, systems and traits to manage the global biosphere? I think this is the question we're all asking ourselves. And the traditional way of looking at this is, well, yes, let's just get down to it. We kind of know what they look like, right? A global carbon tax, for example, something like this.
Mm-hmm.
I think that leaves out the key question of what is the process by which we arrive at a set of traits to sustainably manage a resource. And when you look at some of the history, we see sort of three facts. The first one, and this is a really important one, is that management traits tend to lag behind extraction traits, right? So we develop a system to extract and consume, right? Forest products or water, right? And it's only after we've polluted the river that we realize we need to not pollute the river, and we then set up systems to not do that, right? Littering laws come after littering becomes a problem. Forestry plans emerge after overharvesting, etc. So this is a strong and general pattern. The next thing is that, of course, what we're looking at is a global system. We probably need, because the global biosphere is not just simply a single resource, right? It's not just carbon in the atmosphere or amount of productive land. It's the whole thing, and so it probably will require sort of global scale, complex technical and legal systems to make sure that we understand how we're managing the resource and preserving it in ways that are probably orders of magnitude more tricky than we've dealt with before. And so then the problem becomes, in order to have such a thing, we need some sort of group to be able to express those things, right? We need a global society, right, to have the agency that manages this, or some sort of global cooperative governance system. So then that leads us to the last component, which emerges from the paper, where we've been trying to understand how human groups evolve in the environment over time and look at how that relates. And so, and I'll finally end on this figure, which is that, human groups come to really nicely refined and adaptive traits as a result of a process of cultural evolution where there is a population of those groups, okay? So, and why does that help? When there's a population of groups, those groups can learn from each other, right? Those groups can compete with each other. And that accelerates the process of cultural evolution of those institutions and organizations and technologies that they're using to survive in the environment, or in some cases, for example, go to war. In this case, we're interested in environmental technology and social technology. And so, for example, one of the pieces that I've studied in the past on this is the evolution of lobster fishing on the coast of Maine, down where you are, Andy. And there's a classic example, a colleague of mine at the University of Maine who's since passed away, named Jim Atchison, who studied the lobster gangs of Maine. And these are cooperative fishing groups that are based in a harbor, and they patrol a certain territory in the water, and they harvest the lobsters in the water. Now, it wasn't always like this, right? Because the lobster industry emerged from nothing, and it was individual at first. But they came to be able to cooperate with each other to limit their own consumption of their own lobster in a cooperative way. They gave up over harvesting their own lobsters in order to focus on protecting their boundaries so that other lobstermen wouldn't come in and poach their lobster. So Jim and I, went back through his, 3 decades of research on deep research on this, and sort of tried to understand that process. And it's a really good example of the emergence of a group level system for maintaining local resources that group can take care of.
That's such a great example.
Yeah.
And it reminds me a little bit, there's so much more to say and explore on this. Yesterday I did a conversation with, it reminds me of Eleanor Ostrom's work for sure.
Exactly.
Sort of flipping the disaster of the commons and
Uh-huh.
showing that communities
Uh-huh.
actually don't always do that.
Right. Yeah, precisely. And one of the things, and so in general, my work has been trying to extend Eleanor Ostrom's question, right? And her question has been, how do communities come to manage resources sustainably, and do they? Um, and uh, and what are the nature of the institutions that allow them to do that? And that has been one of the most important piece of research in the entire field of sustainability. And my question to try to extend that is not just what are the institutions that allow us to manage resources sustainably, but how do those institutions evolve? Where do they come from? What's the process by which they happen, and when does that process fail to get us there? And that's why I study the cultural evolution of institutions for environmental management.
I just yesterday did this talk with folks at Global Fishing Watch, which is using
Yeah.
data. They look at this. This is so interesting. And this is not, I'm not going to include this. I'm just saying, I think I want to pause and then see if we can find a time to really dig in more. This is
Sure.
data on fishing activity.
Mm-hmm.
And look at the big holes.
Look at the
Those
whole.
holes are around the Maldives and the Chagos Archipelago.
Yeah, of course.
And that's because there are areas where there's some governance. And it just shows you the possibility of using data to reveal
Yes.
bad and good action and drive things forward too. Just sort of the awareness of things sometimes starts to change.
Lovely data set, spatial data set there.
Oh my God! And they just did this new paper, extends it to all the industrialization of the oceans. It's traffic and oil fields, and also wind. They're showing like where wind is growing and stuff.
Oh,
It's
wow.
really a great paper.
In order for us to evolve, right, we need a population that is evolving. In order for us to evolve group level traits, like, for example, institutions to manage resources sustainably, you need a population of groups, right? And we've done this many times. And Ostrom's work is an example, and Jim Atchison's work on lobster fisheries in the Gulf of Maine is an example of group level evolution of those institutions to protect those resources. Now, here, this leads us to a problem that we call the population structure problem of the Anthropocene, or even of human evolution generally, which is that on a single planet, with one single complex biosphere to manage, there's one resource, right? But we do not have a population of groups that are learning to manage that resource. We don't really even have one group that's managing that resource. Instead, we have a population of groups that are smaller than our biosphere is. And this leads to a fundamental structural problem, not just in the tragedy of the commons way, because it's clearly that problem, but also in the structure of evolutionary processes. You need a population of groups in order to evolve good solutions. So this is the underlying problem that we uncover here. And that's what this figure is about, where, historical human societies, going back deep into our evolutionary past, start small and local, they get larger, and they become more cooperative, and they sort of become able to control larger and larger amounts of environmental resources. And now we're coming up against societies that are large enough to start dealing with global sustainability frontiers, global environmental challenges. And so we have this population, but the population's at the wrong scale. And so evolution in that population will tend to point us towards competitive interactions around the environment and other things. And so that's the problem. And that's this population structure problem, we call it.
A lot of environmental campaigners and sustainability campaigners talk about leapfrogging.
Yes. Okay.
So we can fill these gaps, that, well, we went through this and now we know ways to do this. And I see this a lot. And at the same time, I've written about a number of examples that seem to indicate we all end up, every group has to relearn, not just relearn the lessons, but is essentially constrained by its incapacities to deal
Right.
with, if you're poor, you can't think about the future. You're just thinking about today, for
Right.
example. So
Yes.
how does that, is leapfrogging kind of a fantastical idea, or could that be an end run?
The end run question is exactly, of course, the focus. And let me, and I will address leapfrogging. So, because I think it's complicated, right? So the general problem. So one problem, right? So we have, for example, climate change, and it's a big issue if we're going to solve climate change. And sort of some of what we're talking about here suggests that this might be hard, right? And so one problem is that sort of patterns of human cultural evolution don't favor global sustainability, don't favor the emergence of climate controls at the global level. And I'm just going to go through this real quick. The bigger problem is that human evolution, cultural evolution, may oppose the emergence of global sustainability traits, right? And then, of course, the ultimate problem, which again is actually in this paper, is that human evolution itself may just not even be sustainable on a single planet. Right? We don't even know that that's the case. And so why? Like, that's really worth thinking about, really worth understanding, because the Anthropocene is a novel event for the history of life on the planet. Our species is a novel species. And when you put those two together, all of a sudden we have this giant problem, right? So you have to ask the question, does it work at all to have a culturally evolving species as effective as ours, and can you maintain that species for an indefinite period on a single planet? We don't even know the answer to that question in theory. So now to come back to your question of so obviously that's not the question we have to answer now. We have to answer the challenge of climate change and take it one step at a time. So for sub-Saharan Africa, for the question of leapfrogging, I think there are two dimensions to it. On the one hand, we've seen sort of technological leapfrogging in various ways already. The famous example, and really one of the only ones that I'm familiar with, and I think it's an important one because it shows how it isn't ubiquitous, is developing nations going straight to cell phone technology and skipping landlines.
Right.
Now, notably, this doesn't happen with wastewater treatment facilities, right, or with potable water, or with health departments. So that is a really important distinction, and I think one that highlights the challenge. Another component of the leapfrogging thing is, well, maybe we hope that there's green development in the developing world, and so they can avoid, say, a carbon-intensive industrial sector. And that's fine, except of course, in a lot of cases, those countries are literally in debt through sort of development finance to the West. So it seems unlikely that it will be easy to make strategic investments in green technology unless they are directly financially superior. And of course, they're not. Otherwise, we'd all be there yesterday, or we would be moving in that direction faster. In some cases, of course they are. So I think the leapfrogging thing is challenging to think of without understanding the implications of inequality between countries. And so, considerations of something like, climate reparations could be useful, because it was, the United States emitted far more than our share of carbon dioxide.
The aspects of governance and development that don't catch up, that don't leapfrog, you can see it vividly everywhere.
Yes, exactly.
And
why is that? And so there's a cultural evolutionary sort of explanation for this, which is that social technology, right? So institutions that help people cooperate. These are very hard to develop. And once they're developed, they're very hard to maintain, as we see in our country today, right? Our government is falling apart. because we're not able to cooperate with each other. And we see that the institutions won't survive, right? If we can't cooperate with each other, the institutions will come apart. If the institutions come apart, our ability to cooperate will decline. And so social technology, right, which is the institutions, are very slippery, and they don't exhibit a ratchet effect in the same way that physical technology often does, right? You have faster internet speeds, and they just get faster because we've mastered how to do that. Same is true for technology generally. So those are the domains in which we can do leapfrogging, and social technology requires not just a long time to develop, but also, importantly, a between group interaction, right? That's important. So you might even worry about the spread of democracy that has happened in the century behind us, and what the fate of democracy will be going forward as a result of the pressures we're talking about in this paper.
One impediment to the end run options, meaning rich countries or the rich part of the world filling those capacity gaps with substantial investment, or let's say forgiving debt as a way to improve the economic conditions in struggling places. One impediment seems to be that I see no evidence of that ever happening. Under the climate treaty, they're starting in Cancun in like 2011, there was this commitment of $100 billion a year, theoretically coming by 2020 or so, and that hasn't happened. And so that the global community isn't acting in the kind of idealized the way that would actually be in the interest of the rich parts of the world. If they had, if you look at this systemically, you can see if you really want a functioning planet going forward, including if you're already rich, and it's a good idea to sort of invest to reduce vulnerabilities and disruptive characteristics of life in poor ones.
I think there's a very real way in which climate change is a wonderful boon for us. It's absolutely going to be one of the worst things we've ever dealt with. It's the hardest problem we've ever dealt with. It has the potential, in all likelihood, to create massive misery. So why could it possibly be a boon? I think that it could be because it exhibits two characteristics. One is it's so clearly shared, right? There's one climate system, and it's very tightly linked to all of our local experiences. And number two, thankfully, because it's so tightly coupled, we're experiencing those costs, like this crazy storm you and I just experienced here in Maine this morning and last night. We're experiencing them all together collectively. And so it really makes it clear that we're in the same boat. Now, importantly, I've indicated sort of in that little figure there are future global sustainability challenges that are unlikely to be so forgiving, right? And so, for example, this may be the pollution of water bodies or groundwater locally, but also simultaneously around the world. And so that could be way more difficult to deal with, for example. And there are other issues along those lines too. So the question is, so how do we do these end runs, and what are they? I think first we need to start with saying, look, it's not hopeless, and so focusing on climate change, right? Not the long-term question, right? Can we survive on the planet? That's a question for thousands of years. For now, we have this question of how do we solve climate change? And I want to say that our ability to solve climate change, like we have to solve it, and then we need to get ready to do it again and again and again. That's what staying on the planet looks like. Okay, and each time it's going to get harder, and we still have to do it. So where do we grasp for hope, right? So I think that it's not hopeless. And one of the first places is there is global environmental policy, right? We created the Montreal Protocol. We eliminated CFCs to a large degree. The ozone hole has been repaired to a surprising degree. We have the UN framework on climate change. We have the Paris Agreement, which, while far from sufficient, is a start. But we can go further back, right? There's the international moratorium on whaling and other things too. For example, the elimination of diseases like smallpox and the abolition of slavery, right? So we've made changes to the way we run our system at the planetary level, which I think suggests that we can make good progress here. And so that's the first, I think, hope for an end run. And I think there are others, but they may not be as apparent. And I think the standard policy approach to thinking about climate change is, well, let's keep making global environmental policy. And of course, I agree. But you'll note that the UN doesn't have the teeth to, enforce a, global carbon tax, whereas a global carbon tax is what we need, right? And so, and I think the policy world has in the last few years become well aware of this with the idea of climate clubs, that we need to draw boundaries around groups and have those groups sort of do well, but also be exclusionary in order to draw people in. So, for example, I think that one of the best examples of this is, something like a treaty. And the EU, the new EU carbon border adjustment mechanism is a carbon tariff that will go into effect in the next 2 years. And importantly, that carbon tariff exists, and this is an important point, because the EU exists, right? The carbon tariff can exist because there is a European government. And it would not if there wasn't. And so the only other way to do it is to build strong treaties, but without a whole. So this is the challenge, right? Can we start building cooperative governance and have that cooperative governance also be expansionist, right? We want to bring other people in, and so. This is why a carbon tariff is a good mechanism, and so I think that's another a possible route to growing our way out of this challenge. But it's not the only one. I think there's some other ways for us to think through it too.
One thing that came to mind through some earlier experiences in reporting is a reimagining of what we think of when we think of national security or national defense. The Defense Department and the State Department are our main buckets that we throw money into to prevent conflict and to respond to it. The USAID, State Department. And after some disasters, I remember when I was covering the Indian Ocean tsunami, 2004,
right?
Aceh province was full of terror. There were terrorists and extremists who were disrupting things there. The U.S. threw a lot of resources, including Navy resources, into responding to the tsunami and the earthquake. And the dynamic, and it wasn't through suppression of these terrorists, it's just the political dynamic, the responding to that blow to development, changed the politics in the area to so and then 2000, when was it? 2000, maybe a decade ago, a couple of advisors to the chiefs of staff threw together a document on sustainability and the military, and it wasn't about green aviation fuel for the jets. It was about strategy. And, and it also included this idea of
a global military concern because it potential for things to destabilize. Right?
Yeah, and it was sort of a grand strategy reconceiving the role of our defense assets, and then in 2017, early days of the Trump administration, the European, there was a meeting in, I think it was in Berlin. I didn't go to the meeting, but I reported on it, of defense folks from around the world, and Trump's defense secretary, who he later bumped, was there. And a European official there, I can't remember her name. You have to go back to my own story. She was stressing, the things that Europe does in unstable parts of Africa, our investments for resilience and the like there, are a part of our defense. They're part of our defense strategy.
Right.
And that strikes me as very promising, considering the size of the buckets of money we spend on that stuff. If you can shift some of that more toward not the capacity to respond to turmoil, but the capacity to limit turmoil,
right,
through development, feels
yes,
promising.
Precisely. And I think we were having a conversation before about this relates to the lessons that were learned and not learned from the pandemic. I think so.
Oh yeah,
is this right? This global shock, and it's a global shock that really grinds everything to a halt. It kills people, social systems, and and economic systems come to their knees, right, in the face of this pandemic. And how do we respond to that? And what is what's the capacity for resilience that would be ideal to establish in that case? And I think at the level of the country, it's very clear. And the United States failed this. Not only did we fail to enact good sort of proactive response when it arrived on our shores, Trump not even realizing or understanding the science and taking it seriously at all. Sorry, it's not so much of a joke. But since that time, it's clear to me, when you think of this as a national threat, that there's a way to deal with future pandemics, and you need an agency that has reserve capacity, that is ready to mobilize basically at a moment's notice if there's a new serious threat. It has the capacity to do national level contact tracing. It has the capacity to support people to do the quarantining that's necessary to stop the thing in its tracks, right? It has the ability to monitor our sort of viral exposure surface. And so that's a really good way to think about, at every step, we should think, how can we build resilience? And I think your point here brings it back to sustainability in terms of our interaction. What is our interaction between groups of humans on the planet when there's no more space to go, right? The more those interactions are conflictual over resources or over anything else, the more that will accelerate a further conflict, right? And so there's a feedback process, which is little path B in the diagram, that goes towards further conflict, right? So failure to cooperate over environmental resources leads to ongoing conflict over environmental resources. Direct competition over them leads to conflict over environmental resources, and finally could lead to direct conflict, and even military engagement. It's a direct chain of events that goes in that direction, which is why we need to steer away from it. And your point about the EU sort of interventions to build resilience in war-torn areas is a really good one.
So I should make a list of these counterexamples. By the way, on the existential threat list, I've written a lot since like 2002. Not a lot compared to my climate reporting, but I've written consistently about asteroid incoming threats from space. Started talking to the folks who are trying to push for planetary development of means to avert that, and I think extraordinary progress has been made. It's kind of the DART mission that nudged an asteroid.
Amazing.
Yeah. So that seems to be another example, although it's a very discrete solution to an epic problem, meaning it's not like climate change. Climate change, the dimensions are
Yeah.
You need dispersed action
Yeah.
on many fronts. So it's super encouraging because it's an example of us looking ahead, saying, the dinosaurs didn't do too well because of these rocks.
Right.
So I don't know.
It's an example, yes.
But is it useful? Is it useful in applying that example to the decarbonization of a growing energy system?
I think you're right, and I think of course, we need the ability to deflect asteroids, and I'm glad that we're working on that with NASA, and I suppose the EU maybe funded some of the DART mission. Did they?
Yeah, it's very, very collaborative. Yeah.
Yeah. And so that's a good sign. But of course, I want to point out, right, it's a technological solution that can be undertaken by a couple of large powers. And whereas what we really need to do on the decarbonization front, there's a lot of technology that needs to be developed and implemented to do climate change effectively, yes. But the bigger challenge is the cooperation component here, right? It's the social technology problem. And so I think it's a good example because I think it's so very different. You can have a couple of leaders say, yep, it's in our interest to do this. Whereas we can still imagine a similar thing. I think there's a big role for leadership in climate change as well.
Yeah.
And it does, it is another example of, have we managed global, protective actions at any scale ever? And we need to study these, and we need to understand what their limitations and what the process of them are. So this is, there's an ongoing, or there isn't rather. I would like, part of my goal here is to make this an active field of inquiry. So it's not
this gets us to the right. Where do we go from here?
Yeah.
So lay out that part of it now.
Sure. So my goal is to create a new global research agenda, which connects the whole piece together, because I want it to be interdisciplinary. It needs fundamentally to be interdisciplinary. And it needs to be global. It needs to be distributed. But there's this huge question which can motivate everyone, which is, can a population of cultural organisms persist on a single planet indefinitely? It's unknown even in theory. And then we can scale it right down to very practical and applied questions here, which is, how do we maintain a social ecological system that is isolated in perpetuity? We don't know how to do that. And even just that fact is really something else, right? So all of human history and human evolutionary history have we been creating and managing social ecological systems? Sure, agriculture being the most intensive one. However, all of those are open, and we're not tracking or limiting the fluxes of water and nutrients. If anything, we're diverting water and nutrients in to our productive zones and kind of ignoring the places we take those things from. We don't know how to draw a hard boundary around an area of space, grow an ecosystem inside it, and maintain a population of humans, period. And that's a really deep research agenda, right? So there's the example of Biosphere 2 in the early 90s, which is a wonderful example because it was something of a press stunt. It was poorly designed from a science perspective. It was not a good experimental design, not good science. But it was exactly the right kind of question to be asking. Right? Can you maintain an ecosystem of some sort that is closed, and can we maintain a group of humans in there? The answer and the lessons that we learned from Biosphere 2 is no, we don't know how to maintain the ecosystem. All sorts of things went wrong with it. We screwed up the atmosphere. The biospherians, I think they were called, started to starve, and they started to fight with each other. So everything went wrong with it, which is a really important example. And what happened as a result of that, unfortunately, was that everyone turned away from this kind of science, which is exactly wrong. So we need not just Biosphere 2. We need to take the Biosphere 2 example and we need to replicate it. We need thousands of them at different scales. They don't all have to have an enclosed atmosphere, but we do need to work on closed loop ecology and how you maintain a system where humans are in that loop. And so, you can do this on organic farms. There's a research agenda that can be spun out now to look at this, right? But even organic farms, that exist today rely on large amounts of material and energetic input.
Right.
Of course they do. And so this is one small piece, right, that we should be working on, because we need those answers. How do you get the answer? How do you come to the question of what is it that we need? What are the social and technical and legal systems that we need at the scale of the planet in order to maintain a closed biosphere at the scale of the planet? Well, maybe we can make some advanced sort of learning on that by doing it at a smaller scale. And importantly, we can have a population of such groups learning from each other to sort of accelerate that cultural evolutionary process. So that's one angle, right? So there's a whole research agenda that we can do here. Yeah.
Well, that's good. I think that's a vital path forward. And although there are these, as I said earlier about Jesse Ausubel saying the human brain doesn't change, therefore technology must. And there's a whole eco-modernist, the Breakthrough Institute et al. Approach to this, which says we're over concerned about space. If we could use technology to create more from less. I've written a lot about agriculture, different models of agriculture. If you get more production out of the same amount of land, at least you might not be able to prove this can go on in perpetuity, but you can prove we can still have the Serengeti and have Africa with 2 billion people, as opposed to one. How much of their approach to this, in the contrast to the limits model, is worth considering, at least in extending our envelope of possibility?
Yeah. So you mean the Breakthrough Initiative?
Yeah. Well, it's about the idea of decoupling our resource needs from the thing called nature.
Yes.
So we're actually, the simplest way to look at this is through agriculture. Africa, if you could triple the productivity of the smallholder farms in sub-Saharan Africa, you can still have a transition to a stable population and work on family, on fertility rates and the like, and or not, so that feels like it at least extends the possibility.
Yeah. Well, I mean, I think so. When it comes to carbon, right, we have yet to, and even just sort of environmentally decoupling generally, we have really yet to show that it continues to be a hope, but we keep using more and more, right?
Yeah.
And so and to me, that concept of, hey, maybe we decouple is lacking a little bit of theoretical rigor, right? So look, we're organisms, right? And the way we have given ourselves these really comfortable lifestyles and been able to sort of control the environment so much is by the use of energy. And when we get more opportunities to use more energy to further control our environment and give ourselves more quality of life, we do it. And so that's a deep process. And so, in economics, there's an awareness of this thing called the Jevons paradox, where you make something more efficient, and then all of a sudden people who use it use it more. And so, there's no hope in just waiting for decoupling. Is my approach to this. But I do think that and in fact, I think the challenge, if anything, um, as some of the sort of thinking goes, from some colleagues of mine, basically, is we need to increase coupling between human groups and the resources that they rely on. Now, of course, the brutal version of this in the past is you run out of your resource and your population does really poorly, right? We're in the modern era. Hopefully we don't have to do it that way, although that will continue to be an issue. And so is there a way for us to, sort of create those kinds of feedbacks in a social and economic way, so that we can do the learning that we need to do, that we need to do in order to evolve new systems of sustainability, right? And so, right. So, and there are a number of different ways to do that, right? This many biospheres project that I'm describing is one of them. Another one is, you can imagine, literally creating incentivized competitions between towns or regions or states that encourage certain types of measurable, sustainable outcomes. Now, the problem there, though, is in order to accelerate that kind of competition and sort of cultural evolution, you need the group at the higher scale to prioritize it and make it happen.
Right.
So it's a catch-22. Yeah.
So I want to ask you one more question, and then ask you about your journey. I know you. We're going on a little bit long here, but this is all really valuable, and I think it'd be valuable for everyone out there. There's one conclusion to your work that could support the idea of Jeff Bezos and Elon Musk and the rest that we need to become an extraplanetary species. That right. Yeah, there isn't room for us because we are energy intensive, and to truly thrive, we need to get out to the moon and Mars and beyond, and become a species of trillions elsewhere, not here on Earth. Mm-hmm. Have you considered that, or what's been the feedback to your paper so far? Is that sort of one way? I have,
actually, there are some folks working on that. This is related, right? And when you think of, I'll come back to Bezos and Musk and their ambitions and sort of how that relates, but when you again look at humans as a novel species, right? And you ask the question, what are they doing, and how is it they have so rapidly covered the globe in a glowing ooze? Right? When you look at humans from space, we are a glowing slime mold that has covered the planet, and you see it at night. And so it should be natural to think, oh my gosh, this glowing ooze might spread off of the planet. So I think there's a really obvious way that we should be asking that question. But I think the point about sustainability and these things, I think a lot of folks on the the liberal end of sort of environmental thought think that the urge to get off world and colonize other places is mistaken for multiple reasons. It might be a waste of resources. Among other things, it's a distraction from solving the problems here. And it might even sort of convince us that we don't need to solve the problems here. I think those are important points. But I disagree that it would be a bad idea to actually work on getting off of the planet. You'll notice that the biosphere stuff, right? That Biosphere 2 project in the 90s in Arizona was framed in terms of both types of science, both sustainability science and space science. The reason it is, of course, is because it does both, right? In order to get off the planet at all, you can't just, it's not good enough to arrive on Mars with a bunch of giant rockets, despite what Elon Musk seems to believe about that. What you need to do is you need to arrive with an entirely functioning, enclosed ecosystem, and we don't know how to do that. And so, yes, we should be pursuing space endeavors, but really only as a way to keep us focused on the task of understanding how to preserve and maintain ecosystems in their entirety when we're still in them. And that's the key, right? So you solve the problem. And just a side note, space is terrible, right?
Yes.
I'm reading a book which is absolutely delightful, which you might want to put up, which is called A City on Mars. And it's about taking a sort of skeptical look at the space settlement agenda. And it's just sort of, it's not so much the agenda as can we do this? And it's a wonderful book, and it just came out. And the real answer is, wow, no, not at all. It's far worse than people would like you to believe. And there's a lot of ignoring of the really hard challenges. We can't do it now, not even close, right? And a lot of it comes down to things like, by Kelly and Zach Weinersmith. So highly recommended. And it's related, and the focus on ecology should not go unnoticed. And they do a good job of highlighting that we don't know how to do that.
I'll have to get them on the webcast.
Yeah, highly recommended. Yeah.
Yeah.
So I think, so my perspective is absolutely we should be pursuing things like trying to survive on the moon because it's so unbelievably hard and hostile. And the things we need to do happen to overlap with another really hard problem that we're ignoring because we're still riding on the beneficence of the Earth. The beneficence of the Earth is running out because we've spent a lot of it, and we need to solve that problem. And one good way to do it is to tinker around out there where we can't breathe. Not because it's going to work,
right?
But because we'll learn the right lessons and be able to bring them back. It'll focus us on the problem of maintaining a small closed biosphere so we can maintain a big one.
That's great. And I'm going to show one more thing here, which to get back to we want to get back to your journey. For anyone else who's particularly if you're a young scientist or getting into science, one of the things you work on is cultural evolution laboratory. Is this correct?
That's right.
Your home. And here's the idea.
That's my webpage. Yep, there we go.
Yeah. So what's cooperate? Tell us a little bit about your journey. How did you get into this fix? Why are you studying such a hard problem and what this is about? Well,
so, so I grew up in a cabin in the woods that my parents made by hand in rural northern Vermont, and we heated with wood. We didn't have any running water. I had an outhouse until I was 11. We took baths with buckets of water that were heated on the wood stove. And so, as a kid, that sort of has meant that, my development just as an individual has sort of spanned a number of sort of stages of sort of technological development and interaction with the environment, which I think has made me always fascinated with the natural world and the ways we use it and integrate with it. So then, after college, my goal was to sort of try to save the world with ecology. And I had a degree in biology and ecology. And I went to Haverford College outside of Philadelphia, and I found myself working at the South Florida Water Management District in South Florida, working on Everglades restoration. And the challenge that I found there was that it seemed really clear from the ecological science that we could restore the Everglades. We basically know what's wrong with it because we were the ones who screwed it up. All we need to do is basically undo some of the chemical pollution and these large water diversions and and we'd be able to get the Everglades back to what it was. But it was simply not occurring despite a large $7 billion project to restore the Everglades. And the reason was very clear. It was that there wasn't the political will to do this, right? We were making money on the sugar industry, and we really did like having water and not spending more money to get water to the metropolitan East Coast in South Florida. And so the human social political dynamics were clearly the problem, not our understanding of ecology. And so my hope to save the world with ecology sort of got put to the side a little bit. My passion for ecology stayed there. But I realized I needed to understand humans in a new way, right? And in a way that was totally conciliant with all of the rest of the natural world, right? We're clearly some kind of special organism, but how do we behave, right? So that led me to my PhD, where I study the evolution of human culture, which is a new field and has unbelievable sort of scientific and applied potential. And so it was then that I studied the emergence of irrigation systems in South India and cooperation in Tamil Nadu, and then eventually moved to the University of Maine, where I sort of tried to make all of this, using what we understand from the way that human culture and behavior and practices and technology evolve to solve sustainability and environmental problems more effectively the first time, right? So it's not enough to know what the solution is. We have to know, how do we get there? So
how do you create the preconditions?
The preconditions
to have that possibility. Yeah, this is deep systems analysis. I don't know if you know Zoe. Do you know Zoe Weil? She runs this thing here in Maine.
No.
The Institute for Humane Education.
Oh, okay, nice.
And my wife also used to work in education on how do you teach kids sustainability concepts? How do you build that into the existing lesson plans of teachers? And Zoe at the Humane Education Institute is trying to do the same thing. And I guess this gets to the value of having you in higher ed. Is there some way to reframe how we think about education, which I was also immersed in at Columbia University,
right?
That can help you amplify and accelerate the possibility of defining the preconditions and getting that into policy and the like?
Oh, wow. Yeah. I mean, that of course is my goal, right? When I teach my undergraduate sustainability course, these themes always come up, and and there's a very real sense that I think the generations that are coming up, now that are maturing now, my teenagers, I think it can feel extremely stuck and extremely hopeless. And despite this paper I just published that says human evolution might work against our ability to solve climate change, there is a lot that we can do, and the concept that, or rather, the model of human processes, group level processes, and human change that people have been handed by the existing social sciences is unbelievably depauperate, right? It's a really simple model of human behavior, which quite honestly doesn't do what it needs to do. And so this is where a rich model that understands sort of processes of adaptation at both the individual and the group levels, that's conciliant with all of natural sciences, and draws on everything we've learned from the social sciences, from economics and psychology and anthropology. That's what we need in order we need that in depth. We need it seriously in order to provide generations of problem solvers who are not just working on the technical components, right? They're working on the social system. They're working on the social technology, so to speak. Yeah.
Well, and you have this Evolve and Sustain. It's an international network.
Yeah.
So
Right.
there are people, you're building kind of, you and others are building a community around this for sure. Maybe talk about that. And this is
Sure.
there's an open invitation, I think, for people still to get involved.
Yes, absolutely, there is. And yeah, so I'll give you another link here, which is also relevant. So Evolve and Sustain is has been an academic network mostly, but trying to sort of pull people together who are interested in doing an interdisciplinary, but still evolutionary approach to understanding sustainability, and work with practitioners as well. And so it's been a slowly growing thing for some time. And recently, in the last year and a half, the pandemic sort of messed up the timing, but we got another small grant to build from the Cultural Evolution Society transformation fund to build to basically extend and expand this project. So one of the things we're doing is we have a sort of series of sort of groups looking at how sort of evolutionary thinking can be useful to forward sustainability efforts in government, in business, in civil society, in education, at the community level, as a grassroots organization. And so we take those insights, and we're going to be meeting in Germany in the next month here to sort of pull those together and create sort of some kind of synthesis to try to operationalize these tools so that people can sort of get a better view on that. So people be welcome to join. What we're looking for here is folks who are mostly interested in doing the research, interested in applying the research. Right? They have a problem and they think that some of these things are relevant. And so one of the things we've done that I'd be happy to quickly mention here is we try to boil down the whole science into 4 sort of usable principles. And these are things that often get ignored, but have direct relevance to how we solve environmental problems. And the first one is, humans have cultural traits. Most of our behavior is influenced by what we've learned from other people. And so the first thing is study the transmission of cultural traits, of sustainable behavior, of environmental cooperation, of environmental laws.
Right.
The next one is the existence of adaptive processes, right? So not just the transmission of some solution, but actually the accumulation of capacity. So a great example of this, and I have a picture. Do I have the picture that I can? I'll just show you this real quick. Is the emergence of let's see here. I think I can.
There is a way for you to share.
I think I can do it real quick. Take that off.
It's a 2-step process. When you hit the share thing, it comes up as a little window that I then move into our stage.
Okay, I have to share. I have to share the whole screen. Share screen. Okay. Share screen. Ah, good. I can select a window. Great.
Yeah, it's coming.
Put that down. There we go. So this is an example of adaptation, right? This is the efficiencies of photovoltaic cells, right? And this is an evolutionary process. And you don't get this type of process of these sorts of ongoing outcomes without the sharing of the information that makes this technology possible. And so that's the second major insight that can be used. And the third one, of course, is about the social technology, the evolution of cooperative governance. And then finally, we have a fourth sort of concept as well. But I want to throw this up here because we have an artist who's involved, and we're trying to sort of create some interactive, sort of engaging art and infographics around this. And so this is just a sort of sketchy version of the first one of these applied frontiers, which is, how does the cultural, practice spread? And you can look at examples such as, this is the Extinction Rebellion in the UK. And it's important also to think you can study, and we should be studying and thinking about the emergence of bad examples, right? The spread of things which are the problem. And in a lot of ways, a lot of the adaptations in modern life are adaptations because they're beneficial for us, but they have these environmental challenges. And so that's really important to acknowledge, because that makes it easier for us to focus on what needs to be changed.
Oh, this is great. And I'd like to, again, advance some of that. How do you visualize this stuff in ways that stick as well? And I guess we've done this. We got your trajectory. We've got what's needed now, which is a lot more brains tied into getting this traction and understanding at all these scales. Yeah. And we've got the basic conclusions in the paper. Is there any last call out you want to make for who needs to be thinking about this and acting on this?
Yeah, thank you. I think we
or funding
it. I think for the focus for me, of course, is the learning and the research, and the learning and the research that has not been happening, in part because I think we're thinking about the problem the wrong way. And so, absolutely, there is a big blind spot in the funding for sort of environmental research. It's not forward-looking, right? The environmental research that goes on, environmental social science that gets funded, is either sort of basic social science, or it's applied in a sort of, there's some current problems, let's try to solve these. We need to be far more aggressive and forward-looking in the way that we study how humans survive in the environment, and understanding these two concepts. Number one, we don't even know in theory if our species can survive on the planet indefinitely. That's really not understood. We have no idea about that. And number two, we obviously don't know yet how to maintain a closed system ecology with humans in it. We have not managed that. And so those are really concrete ideas that show that we need to do a lot more funding of this kind of research. And the research program is ready to go. We need to start solving that problem. And the nice part about it here is that it is a deeply applied research program with benefits that will emerge and in real time as we do it. So I would say that's one, right? We need national, international funding to try to move in this direction. And it's not just the biosphere project. There are a lot of other components of this. So understanding how humans sort of have evolved in terms of their management of the environment in general is, there are not a lot more people beyond me trying to address that question in that way. The other thing, though, is we can't lose track of the challenge of building global cooperative environmental governance. And there's no easy way to do that. It will always be difficult, and we can't lose track of that either. And again, there is also a research agenda to be added there. But I think there's a lot of research to be done. And I think if you are not in, academia, you're not in research, you can still push for these ideas at the political level, because the key is, what are humans good at? We are really good at group level learning, right? And so if you are a state or you live in a town, and the town can achieve something novel, or you see another town that does, It's the spreading of those ideas between towns, the beneficial ones between towns. That's the key. That's where humans make our real progress. And so leveraging that is something that will take all of us.
Oh boy, I can't agree more. And I'm looking forward, now that I'm here in Maine, I'm looking forward to becoming more actively involved in that at the local scale, whether it's managing our resources like lobsters sustainably or our shorelines, as I've experienced this morning. The storms of to me, they're just a time machine. These storm impacts we see now are showing us what's going to be normal briefly before it becomes abnormal again a few decades from now. There's this business about the investment challenge, I think, is really important. And I just want to, you've been super generous with your time. I want to play you a little.
Yeah, I'll have to jump off here in a second.
Yeah, which is fine. I appreciate this. So I think, can you see what I'm looking at? It looks like my Twitter feed. I don't know if you know the social scientist Indra Overland, but he's over in Europe, and he and Sovacool did a paper, came out a couple of years ago, on the lack of research on the social science aspects of solving climate change.
That is very much our message. So I think while we, this is Benjamin Sovacool, my co-author, and myself, while we would agree with all of you about, we have very much a similar perspective, we also, there's a certain point where we take a different line. And we see that in technological research in the natural science, or if you take natural sciences first in terms of understanding climate change, there are many things we don't know. There are many things that are not known about how it plays out. But a lot of the basics are quite well established and well recognized. And the same goes for the technological solutions. When it comes to, if you look at solar power, wind power, energy storage, there's been quite a lot of progress in those areas, and the costs have been plummeting and are continuing to plummet.
Yes, there we go.
Seen from our perspective, things look pretty promising in that area. The real challenge, the intractable challenge that we haven't solved yet, is how to get people to use all of those technological solutions. And that's about changing politics, changing human behavior, changing culture, changing institutions. So that's political science, economics, law, sociology, and so on. And the way we see it, those are actually now, whether one likes it or not, those are the main puzzles, the main remaining barriers to mitigating climate change. And those are the areas, research into those areas, that only get 0.12% of the research funding between 1990 and 2019, based on analysis of $1.3 trillion of funding. So we've
that's quite a sobering finding.
That is, I wasn't aware of that research. Of course, I was aware of the funding.
Yeah.
But I will be citing that paper shortly. The challenge of making this pitch to the federal agencies is important, and it's something I'd like to prioritize as well.
Great.
So actually, I'd like to talk with you about that at some point. But I'm going to need to wrap it up, Andy.
No, this was wonderful, and a great introduction to the deep issues and opportunities that lie underneath what looks like just a simple paper. And I hope people, through this Sustain What webcast and more that we can do going forward, can see that potential to examine these questions about end runs or innovations in our cultural sphere as being as important as when we think about a solar panel or the like. Thanks, Tim Waring, for spending time, and we'll share this and try to build a conversation and not only that, but build results.